Okay, so with this video we're going to share with you some new abilities that 2015 R3 Microvellum can do and how I'm able to modify the data. Well, actually I'm simplifying the data now because of this new ability. I'd like to share with you what changes I'm making with the library data and how I'm taking advantage of these new features. So right here I have three products. They're a two-drawer base. I've turned on perfect grain, and by using the spec groups, each of these cabinets has different material that's being used on the doors and the finished ends. Top one has no grain. Middle one, the material, the 4x8 sheet is grained along the length, and the bottom one, the 4x8 material, is selected. The grain is going, along the width, and we can of course do that in the material file. So in the globals, we've always had this perfect grain. I've had this selection on. It works the same if you turn it off. And we've always had the drawer front grain direction, and previously it was a checkbox, which is odd. It was because that's when it was developed. We did not have combo boxes. So now you can, using a combo box, I'm going to set these all to be length. For the door and drawers, they're now separate. Obviously, if you turn on perfect grain and you had one set like how it was, it'll override that. It'll just do length on all of them. But generally, you wouldn't have that combination on. So let's just test this out with length, length, length. I went ahead and separated these three out, just for the slight chance maybe you need to. So those are set on, and let's make a nest and see what happens. I've also renumbered these so we can tell in the nest. So cabinet 1, 2, 3 in that order, so we can compare the results. So here are the doors. I'm also going to loop in these finished ends here. I want to throw those in because they're the same material. See what we get here. Obviously I'm doing a lot of pausing to save you time. There we go, that looks better. So here is the material. It's not grained, so it just threw them wherever. Here the material is grain length, so the parts are appropriately oriented. And that is cabinet 2. Then cabinet 3, because the material is grained width, it had to turn the parts. So that seems to be working. Let's test it the other way. So I want to put all these to be parts. I want grain width. Once I get through this, I'll show you how I'm doing this too. I'll show you the whoops. Okay, so same material, selected the grain width material and the vertical grain, and then the grain or non-grain material. Have those turned on. Process these. So the non-grain material, same thing. Cabinet 1 just does the same. So now cabinet 2, vertical grain length sheet, and it's turned them that way, and then these are turned that way. So the end result is the parts will end up being appropriately grained. So this previously, in order to do this, we would, especially for drawer fronts, we had that option to vertical grain or horizontal grain the drawer front. In order to do that, we had to rotate. In the data, we had to rotate the parts. So we ended up with formulas that previously looked like this. All this extra overhead, now it's just simply that. So I've gone from these unnecessarily complex to that, and all base points are now just a number. Hardware rotation are just, we no longer have to do these formulas anymore of flipping, the width becomes the length and length becomes the width. Is what we had to do in the past. So how did we do this? So you may be familiar with this grain combo box here. Force width, none, or force length. At the time of this recording, we don't have access to the formula in here. Has to do with, because it's also sharing with this checkbox, but so in order to put a formula in here, we need to go through the spreadsheet. We go to a door. Can't see it from here, so you open up this and hide. Okay, so column J is that grain, include routes and borders column. So this is it. Just this one formula is how it all happens. So let's step through this real quick. So first thing it checks to see is the door, or if it's a finished end, the finished end, or the drawer front grain direction is set to none. And that will just turn it off. And the advantage of that may be there's a slight chance, I don't even know if it's measurable, but this function here potentially could have an impact on performance. I don't even know if it's measurable, but just in case, if you set that to none, it just immediately shuts down just like it was before. But we're assuming, in this case, it's set to width or length, so we're going to go to this. So the next thing it checks is this particular material, is it even grained? And what we use is a custom function called material property, and it's going to the M workbook and looking on column 6. I'll show you that really quick. So column 6 is this, and this comes in from the database, and it's a flag. 0 is no grain, 1 is grain length, and 2, which is like this, for example, this new one, 2 is a grained width. So we know, by looking there, we know what the material is at this moment in time. So if the material, like in our example cabinet 1, has no grain, again, it'll just shut off. But if it has grain, then we go here. So if it's length, we're going to be a 2, otherwise a 4. And those refer to 0 is none, 2 is force length, 4 is force width. Now if the don't allow routes is included, which doesn't really apply to in this case, here are the other numbers, but for the sake of this formula, all we need to worry about is this. So that's it. Once I set up a working test example, just came into my trusty Library Designer utility, and you will see that I just visited my door subassemblies. This doesn't apply to MDF or wood, solid wood, just really the slab. And really the first part, these other two are for something else, but this first part here, we have a part grain location, so I just put Mr. Formula in there and then updated my library, and seems to work great. So what I'm working on now is I'm searching using Library Designer. I'm searching through all the locations in the library that previously used this. Drawer front grain direction equals 1, and I'm simplifying it, or really removing it, because it's no longer needed. So, like, as you can see, all the examples so far that I found. So once again, another small step towards a simpler, easier to understand library. It's just a lot better. You come in here and your door or your drawer front, the height equals the top drawer front height. The width equals the drawer front width calc. And previously, we were, sometimes this was 6 and sometimes that was 6 and vice versa. And it was even inside of here too. This had to flip, and now it's just equals height equals width. And the base point is always the same. The Y rotation is always the same. Hardware that interact with these drawer fronts, simpler. Pulls are no longer having to rotate like they did before. It's just so much better. So I wanted to communicate that to everybody so they can understand what's coming and perhaps work with people and other libraries out there to deploy the same functionality. Let me know if you have any questions or if maybe there's something I've overlooked. Yeah, keep the feedback coming. Thanks.